So we're going to walk through one final big example to kind of pull everything together. So I've written and I'm going to show you a collection of classes that describes items sold at a store. So we're not thinking about a big full grocery store, but sort of maybe a small gas station size convenience store that's basically going to sell some food items, some beverages, and some personal items. So all of our items are going to be described by the brand name and price. Price is missing there, as well as whether or not their sale is restricted. So this would be, you could think about, you'd want a special symbol to pop up at the cash register if the cashier has to check ID. In addition to that, beverages are also going to be described by the type of container they're in, glass, plastic, or cardboard, for example. Food is described by a weight. And then we're going to have an interface to represent taxable items and an interface to represent items that might expire. We're going to create an inventory list, and then we're going to print out all the restricted items and print out all the items that are expiring. So this is kind of a general picture of all the classes. So at the very top of our hierarchy, we have store item. This is our main parent class. And store item is going to be abstract because we're never going to create an item in our store inventory that's just an item that isn't one of these categories, one of these more specific categories. Now, of course, you might be able to think of items that don't fall into these categories, but the solution to that would be to make more child classes, okay? But in general, a store item is just too general. It doesn't make sense to create a generic item that isn't more specific than that. So store item is going to be an abstract class. Then one of its child classes is food, and I'm also going to make food an abstract class because I have two child classes: perishable, meaning things like produce and dairy, things that expire, and non-perishable, so soup, crackers, cookies, things like that. So for me, I'm going to say that I'm never going to have a generic piece of food that isn't either perishable or non-perishable. All my food's going to fall into one of those categories, so I'm going to make food also an abstract class. So in this example, I have an abstract parent class, an abstract child class, and then two concrete classes that are child classes of that. Also descending from store item, so also another child class is going to be beverage. Now I am going to make beverage a concrete class, not an abstract class, because I think does make sense you'd have just a generic kind of beverage. But I am going to also add child classes, so soda is going to be a class and beer is going to be a class. So I could instantiate an object of type beverage or type soda or type beer. So here I have an abstract parent class, a concrete child class, and then two concrete child classes from that. Then I've got a personal item. I'm also going to be concrete, and inheriting from that is a medicine class and a personal care item class. Okay, so this is the general layout of my class structure. So let's take a look at the actual classes, starting with store item. So this is our main top parent class. So store item is abstract and it implements comparable, meaning if we want to be able to sort our inventory list, we're going to need a way to compare two items, and we'll do that here. I've said that all store items are described by a brand, a name, whether their sale is restricted, as well as a price. So my constructor takes in all that information. I didn't think it made sense to have any defaults, right? I think I really need all of those pieces of information supplied to me, so I don't have any additional constructors. I just have the one constructor. I've got all my getters and setters with a validity check on the setter for price. And here note, as we've seen before, that typically getters that return a Boolean value start with is instead of starting with get. So I've got is restricted instead of get restricted. I've got a toString that prints out the brand and the name followed by the price. And then if the item is restricted, it prints out in parentheses that the sale is restricted. And if the item is not restricted, it just doesn't print out, doesn't concatenate anything else onto the text representation. This is an example of the ternary operator, and using the ternary operator in text output like this is a great way to use it. It just is a nice way. Instead of having a conditional, an if-else branch inside your toString, you can just have this one line to say, hey, if this item is restricted, question mark, that's the syntax, return this string. And otherwise, colon, that's part of the syntax, return this string. Then I've got my equals method, and I've said that if two items have the same name and brand, ignoring their capitalization, then they're equal, they're logically equivalent. And then notice my equals header, public Boolean equals with parameter type object. Notice also I'm using my override annotation. And then I've got my compare to method, again with the override annotation. I'm taking in an object of type store item since I did use the generics in my class header. The way I've decided to sort my items is that I'm going to sort them first by brand and then by name. So if the brands are equal, they're the same brand, I'll move on to comparing the name. But otherwise, so if they're different brands, then I just sort by brand. And then I have an abstract method representing instructions about ordering that item. So all the items in my store are going to need to be ordered. So because all child classes need to have this functionality, I put this method in the parent class. But all of the items in my store probably have a little bit of a different process or a different distributor that they're going to be ordered from. So they're all going to have different implementations. So I made this method abstract. And that means that all of my child classes have to implement this method. So that's the very top of my hierarchy, the store item. So let's look down this branch now at food. Actually, before we do that, let's flip over quick to the two interfaces. Here's my taxable interface. And here I have one method that returns a double, and it's just called taxed price. So what we're saying is if an item is taxable, I want to provide a method that I can retrieve the taxed price. And I included a constant in this interface to represent the tax rate. Perhaps this is our state or county or whatever it is, the default tax rate that's used. Now a class would have an option of using their own tax rate, or they can just reference this constant value from the interface. Then I have another interface, expirable, and this has just one method, check expiration status. Okay, so let's look at my food classes. Here's the first class, and I said again, food was abstract because it doesn't make sense to have just a general food item that isn't either perishable or non-perishable. And food extends store items. So a food, in my example, food is an item at my store, so the inheritance relationship fits. I added on one instance data variable for weight. I said that food was described by its weight. Now here, I use a constant to represent that food is not restricted. So I said that some items in my store are restricted for their sale and some are not. Well, I don't think food is restricted, right? We let anybody buy any type of food. So because any food object is never going to be restricted, instead of taking the restricted variable in as a parameter, I just defined a constant. And then in my constructor, I only take in the name, brand, price, and weight. And when I invoke the parent constructor, which is the store item constructor, I pass in the name, the brand, and the price, but I pass in that constant value for restricted status being false. So sometimes when you have inheritance relationships like this with multiple classes, some classes need to take in some information as a parameter, and other classes can set that information as a constant. So you have to think about, for this class, is a particular variable going to vary? Well, for us, food is never going to be restricted. So why would I take it in as a parameter if I expect it always to be false? I don't need to take it in as a parameter. If it's always going to be false, I'm just going to set it as a constant. And then when someone creates an object of type food, they never have to tell me that it's false. I just know that it's false. So you want to think about that in your class hierarchy. If there's information you can encapsulate right with the class that isn't going to change based on the object that the user creates, you want to do that because it's more in line with what the object is, and of course it also makes it easier on the person using your class. So in my food constructor, I invoke my parent constructor, I initialize the child variable, I've got a getter and a setter with a validity check. I override the toString to add on some more information, so I'm invoking the store item version, the parent version, and then I add on that this is a food item and that's the weight. Now my abstract food class had two child classes, perishable and non-perishable. Notice that food did not override the order item method, and that's okay because food is also abstract. But perishable and non-perishable are concrete classes, so they are going to have to override that method. So here I've got perishable food extending food. So food is its parent class, and you could think about store item as its grandparent class. And I've also said that food implements expirable. So my food items will have an expiration date. My perishable food items will have an expiration date. Okay, so this is part of the functionality or behavior associated with perishable food is that it expires. Okay. So here's my constructor. My constructor just takes in the name, the brand, the price, and the weight and calls the parent constructor in the food class with that information. And then I invoke the check expiration status method, which here I just have a simple print line. And here's where I implement order item. So I'm saying for my perishable food, my process is that I order this food from a local farm. Now, my non-perishable food class extends food, but it doesn't implement expirable because that's kind of the definition of non-perishable food. It doesn't really have an expiration date. And of course, some, food will expire eventually, but we'll just ignore that case for now. I'm saying that my non-perishable food, I'm keeping it on the shelves forever. Okay, so there's my constructor. This is a pretty small class. I'm not adding on anything additional, and that's okay. That's also common with larger class hierarchies like this, is that sometimes you'll write a child class just to kind of represent that particular type of object, but you might not have much in the class, and that's okay. I override my order item method. So for my non-perishable food, my process is I'm just ordering from the cheapest supplier I can find. Okay, let's look now at the beverage line. So I said that my beverage was a concrete class, not an abstract class, so I can instantiate it. It extends store items, and my beverages are all taxable. So this implements the taxable interface. I did not implement taxable in store item because food isn't taxable when you buy it at the store. So because not all of the child classes are taxable, I didn't implement that interface in the parent class. Instead, I left it to the child classes to decide, and a beverage is taxable, so I implement that interface here. I use an enum to declare the container type as either plastic, glass, cardboard, or aluminum, and then I add in a private instance data variable to represent the container type. So my constructor for beverages takes in the name, the brand, the price, and my constructor for beverages does take in a parameter that represents whether or not the beverage is restricted, because some beverages such as alcohol are going to be restricted and other beverages such as juice are not. So because this information is going to vary in my beverage class and all its descendants, I do take it in as a parameter instead of setting it as a constant. And then I also take in the container type. My call to super invokes the store item constructor because that's the parent, and then I set the child instance data variable. I update my toString to include the description of the container type, and then I have to implement taxed price because I implement that method, the taxable interface. And here in this method, I just say, well, get the price and then add on the tax, which is the price times the tax rate. And again, tax rate is that constant that I've inherited from my taxable interface. I have to override my order item method, so I'm just saying order this beverage from whatever distributor. Now, in my soda class, here, in the constructor, I take in the name, the brand, the price, and the container type, but I don't take in the restricted status. I set a constant for that because soda isn't restricted. If soda was restricted for some reason, or some were restricted, some weren't, I would take it in as a parameter. So then I invoke the constructor of the beverage type. Note that the soda objects do implement taxable. I don't have to say implements taxable, because I did that in beverage, and so I get to inherit that into soda. So soda is taxable, but I don't have to explicitly say that because the parent class said that. So for soda, again, I got my constructor, and I also declared an additional soda tax. So let's say there's a 50-cent surcharge on sodas because the state's trying to get us to reduce our soda consumption. So here I override the tax price method, and I invoke super.taxedPrice, which is the tax price that we calculated in beverage, and then I add on that additional soda charge, that soda fee or soda tax. Okay, so this is overriding the method from beverage, invoking the method from beverage, and then doing a little something extra, which is adding on the soda tax. Okay, here's my beer. In beer, I do also have a constant for restricted status because it's true. We're always going to restrict the sale of beer. We always need to check ID. So I don't need to take that information in as a parameter. I know its value is always going to be true. And here I override order item. And actually, let me change this. Let's start by invoking the parent version. So we want to use the beverage version, which was order from a beverage distributor, and then we'll say for beers, preference for local breweries. So that's going to be our process for ordering beer. So again, you can see that you can use any combination of either totally inheriting the parent version like we did for soda. Here we didn't override the order method at all, or you can change it, replace it completely like I originally had, or you can invoke the parent version and then do something a little extra. Okay, so my last line of classes is the personal item side of things, and here I said personal item again was concrete because I can create an object that's a personal care. This could be like a pen or something. It is these items are taxable, so I implement taxable. I've got my constructor. I don't know if some of my items might be restricted, some might not, so I leave that as a parameter. There's my toString, my taxed price, and my order item. Inheriting from personal item is medicine. Some medicines are restricted, some are not. So again, I take that in as a parameter. This class implements expirable. So my medicines they have an expiration date, so I implement expirable. Now note also that medicines are also taxable. Again, I don't have to explicitly say that because the parent class personal item implemented taxable, so I don't have to include that here, but medicine extends personal item. It implements expirable, and it also implements taxable. So there's my constructor, my check expiration status because it implements expirable, and then I overrided the order item method to say we're ordering from a pharmacy. Here's my personal care item. The sale of personal care items like soap and shampoo and things is not restricted, so I set that to false in a constant, and I don't take it in as a parameter. So there's all my classes. Here's what my driver program looks like. I just create a bunch of stuff, right? So here you can see I'm creating some perishable food items, some non-perishable food items. When I create beverages, I have to specify for just a general beverage whether or not it's restricted, right? And I have to specify the container type. For a soda, I do not have to specify whether it's restricted because we know that it never is. For beer, I also do not have to specify a restriction type because we know that it always is. Now, it might have been useful in my beverage class to actually include a second constructor that didn't take in restricted and set it to false. Since that's sort of the default value, most of my other beverages are not going to be restricted. You'd have to think about whether you want to include that. Then I create a medicine item that is restricted, cold medicine, you have to show ID for that. And I have a medicine item that is not, just regular old pain reliever. And then here's a personal care item. So there's all my inventory list. Now I'm just going to do a couple things. I'm just going to print it out as I created it, so that would be unsorted. Then I'm going to sort it using collections.sort and print it out again. Remember that our compare to method said we sort things by brand first and then name. Then I'm going to go through and I'm going to order everything in my inventory list. Now I can invoke the order item on any the order item method on any store item object because the order item method exists in store item. It's abstract, but the compiler doesn't care. Compiler just cares that it exists. Okay. Next up, I want to print out all the taxed prices. So I go through my list and I check and see if an item is an instance of taxable. If it is, I temporarily cast it to be that type. And this is just another syntax for casting. So you don't have to create a local variable. You can also just do it in parentheses like this. And I use that to then invoke the taxed price, print it out. And then I do the same thing for my expirable item. So I go through my store inventory, I see if it's expiring, and then I check the expiration status after casting. So again, you need the instance of and the cast. And I could do one more thing. Let's add in one more here. Let's say we want to print out everything that comes in an aluminum can because recycling day is coming. So we can go through our list and we can say if the store item, if the item is an instance of beverage. So again, you can use the instance of with either an abstract class or a concrete class or an interface. Then we'll use our local variable, cast it, and then we'll say if bev.get, I always forget my getters and setters for those enum variables. Sorry about that. It's just a brain block I have with that. I don't know why. Okay, so there's my getter setter. So now I can say if the beverage dot get container type dot equals container type dot aluminum. Let's say check recycling. Okay, so and the container type enum, because it's in the beverage class, the way I access it is beverage.containerType, because I declared that enum inside of this class rather than in its own file. So that's the syntax for that. So let's run this program and see our big output here. So we start out with our unsorted inventory, and you'll see this is listed just in the order we added it. It invokes the proper toString method for each kind of item. So for the food items, it invokes the food toString, which includes the weight. For the beverage items, it invokes the beverage toString, which includes the type. And all of those, of course, invoke the parent, because they all said super.toString, so that invokes the store item version. When the items that are restricted, they list that information. Okay, so then we sort our list, and you can see now our inventory is sorted by brand, followed by the name. Okay, then we print out we order all of our inventory, so you can see the correct order method being invoked on each object. Then just the taxing information printing out. Now you can see that because of precision and how doubles work, we're getting pretty ugly output for the price, so we'd want to do some formatting there. But these are all the taxable items, and if you do the math, you'll see that the soda tax is correctly applied to our Diet Pepsi. And then we've got our checking our expirations of all of our perishable items, as well as our medicine, so that's anything that implements expirable. And we've got our aluminum check for our Diet Pepsi. So that is one big old example of abstract classes, interfaces, parent-child classes, polymorphism, kind of everything we've been talking about in the last several lectures, last several series of videos. So take some time with these classes, make sure you understand how everything's laid out, why certain decisions were made in terms of what's abstract, what is concrete in terms of where constants were used versus where parameters were used, in terms of where interfaces were used versus classes. So for example, make sure you understand why taxable and expirable were interfaces instead of being part of the class hierarchy, right? And the reason for that is really that these represent sort of descriptive functionality of each item as opposed to something, the core idea of what an item is. And also these interfaces apply across the hierarchy structure, right? So we had both medicine and perishable foods that were expirable, but these aren't related through inheritance. So it wouldn't make sense to kind of put a parent class in here that then perishable food and medicine, like that wouldn't make sense. So it makes sense to sort of have this outside interface of taxable, and then you can just link it up to whichever individual classes you need. I'm sorry, for expirable. And same thing with taxable, and then you just link it up to the classes that you need. Okay, so make sure that idea makes sense. Again, spend some time with the layout of these classes as well as with the actual code, and make sure that kind of you're seeing the big picture with these classes.